Okay, we're going to look at section 1.1 as an overview, and we start by studying the rectangular coordinate system. So we would draw an x and a y axis intersecting at 0, 0, the origin. And we'll label these axes. We have the x going left to right and the y bottom to top. This is called a Cartesian plane or coordinate plane. And we're going to plot points, and we're going to identify which quadrant they lie in, or if they lie on a quadrant axis, one of these axes. The quadrants are numbered if you draw a C for coordinate plane or Cartesian plane in that order, 1, 2, 3, 4 as you go around. Now the x coordinate in an ordered pair, or the first coordinate, is called the abscissa. The second coordinate is just usually called the ordinate, or we say just usually the y coordinate, and we will use x and y to represent these points, and these two coordinates make a point on this grid over here. So first of all, we'll plot a few points. I will say that point 1 is negative 1, 3. So I would start in the center where the x and y axis intersect. Now I would count left 1, and from there I would go up positive 3 in the y direction. 1, 2, 3, and put 1 point at the end of going left and then right. That would be that point. So you should be able to plot points already on one of these XY planes, and to tell which quadrant the point lies in. So this negative 1, 3 lies in quadrant 2. And you should be able to plot points that land on an axis. For example, we'll say point 2 is 5, 0, where the horizontal distance, or x, is 5. So I would start at the origin, go right 5. Now I would stay there because the y value there is 0. And that lies on the x-axis. Now on the graphing calculator, we have window settings that are similar to, like if I was to put a box around this coordinate plane, and let's say I had marked off 10 units in every direction from the center, on the graphing calculator, our x-min value under the window settings would be negative 10, and it has an x-max value. The largest x used on that particular screen is 10, and there's something called x-scale. It's each little tick mark is how much it is equal to, so it would be 1 is the number of units per tick mark, and then the y-min for this particular grid would be negative 10, y max 10, and the y scale of 1. And all of these can be changed on the graphing calculator, and they're located under the window feature. Now when we get to application problems, these will usually go way beyond negative 10 to 10, but this is like our standard viewing window, and you can get all of these values into your window settings by just pressing on the calculator zoom 6. Zoom 6 is the same thing. It's called the standard viewing window on the graphing calculator. Okay, let's say I was trying to plot the following points. Negative 30, 20, negative 50, 10, and 7, 30. If I was on the graphing calculator, I would have to have a viewing window where the x-min was at least as small as any of the x values. So one viewing window that would work, I could set my x-min to be, let's say, negative 60. I'll go a little bit lower than my lowest x. Now my x-max for this particular point needs to be 7 or larger, so I can let it be 10. And my x scale could be what I'm going to count by on the tick mark, so I can let it be, say, 2. Now, for all these points to show up, my y-min would have to be lower than my smallest y value, which my smallest y value here is 10, so I could let it be a little smaller, say 0. My y max must be large enough to graph any of these y values, so I would let it be a little larger than the largest, which is I'm going to let it be 40. And then for my scale, I could count by whatever I wanted to. Going from 0 to 40, I would probably want to count by 5s. So you're going to be asked to set some viewing windows that would incorporate a certain set of data that you're going to be given. Just make sure, again, that your x values that you choose for your min and max are low enough and high enough to include all the x values, and same thing for the y values. Now you may be given a viewing window for the graphing calculator and asked to identify x, min, max, scale. So let's say we were given this particular window. Let's say we had 9, -9, and 5 to -5. And we have these tick marks in here. To find the x min, there's a formula that says x max, which is 5, minus x min, which is -5, divided by number of tick marks. So if you notice, there's 1, 2, 3, 4, 5, 6, there's 10 tick marks. 5 plus 5, I get 10 divided by 10 equals 1. So my my x scale would be 1. X min here would be -5, x max, of course, is 5. And to find the scale, you just say max minus min divided by number of tick marks. So scale is equal to the max value minus the min divided by the number of tick or division marks on the axis. Now for this particular problem, the y min, of course, is -9, and the y max would be 9. Now to find your y scale, we could just take the max 9 minus the min divided by 1, 2, 3, 4, 5, 6 tick or division marks. That would be 18 divided by 6, and so the scale is 3, which means we would count by 3. If we started at the origin and went up, we count 3, 6, 9. You can just look at that and figure it out also most of the time without using that formula. We'll also be trying to find the distance between two particular points. Let's say point 1 is given by -4, 3, and point 2 is given by 2, 1. If I want to know the distance between these 2 points, since they don't lie on a horizontal or vertical line, I can't just count them. There's a formula we use, which is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I would first label my ordered pairs. The first pair I'd call x1, y1. The second ordered pair, x2, y2. I will plug those into this formula to come out with 2 minus -4 quantity squared plus my second y over here, 1 minus my first y squared. 2 minus -4 is 2 plus 4 is 6 squared is 36 plus 1 minus 3 is -2 and -2 squared is 4. So I get the square root of 40, and in my math lab they want you to reduce this and not using a decimal. So a quick review is you find a perfect square that divides into 40 evenly, like 4, and then it's 4 times 10, of course, is 40, and since 4 has a square root, you take it outside the radical, it's 2, and it leaves the square root of 10. That would be the exact final answer. After finding distance, we'll also find the midpoint of this segment, which means the point in the middle. If I drew these 2 points and connected them, the point in the exact middle is just the average of the coordinates. So when you add the x's and divide by 2, I get the average of them, and I add the y coordinates and divide by 2, I get the average. Just like getting a test average, you add and divide by 2. So for this problem, the midpoint would be negative 4 plus 2. That's my x's added and averaged, comma, my y values averaged. I would get negative 2 over 2 is negative 1, comma, 2. 3 plus 1, 4 divided by 2 is 2. That would be the point in the middle of the segment. This will come into play when we go to studying circles later on in the chapter. Then you're going to be asked to plot some equations, graph them, and find their intercepts. So first, let's just look at an equation and make sure we understand how to tell if an ordered pair belongs to that equation or not. So I'm asking, does the point, say 0, negative 3, belong to this equation? Well, this is x, and this is y. So when I put those in place of those variables and do the math that's indicated, the question is, does it equal what it's supposed to equal, the 9? Well, 0 plus 9 does equal 9. So the first one, this would be yes. This point would be on the graph of this if I was to graph that. And let's say we were asked, does the ordered pair square root of 3 belong to this particular equation? So I will just substitute my x value in and square it, my y value in and square it, and I want that sum to be 9 in order for this point to belong to this equation and to be on its graph. But when I square radical 3, I get square root of 9, which is 3, and again I get a 3, and that does not add up to 9, so this point does not lie on the graph, or does not belong to the equation. So let's actually take an equation and go through graphing it and then finding its intercepts, x and y. Okay, first I'm going to draw a graph, and we'll state the intercepts to make sure everyone understands what intercepts are and how we could just look at a graph to find the intercepts. Let's say we have a graph crossing through here. Looks something like that, and I want to know the x and the y intercepts. The x-intercepts lie on the x-axis. It's the points where the graph crosses or intercepts the x-axis. So I'm going to put circles there. The x-intercepts would be the x values negative 2, 1, and 4. They can be written as ordered pairs also, because all the y values will be 0 for each of these. And of course it only has one y-intercept, that's where it crosses the y-axis, and this one crosses at negative 1. That's easy from a graph, not hardly as easy from an equation. So let's say we have the equation y equals 2x plus 3, and we're asked to find the x and the y-intercepts by algebra without graphing. So an x-intercept is when the y value equals 0, so I would just make the y a 0, have a little algebra 1 equation, I'll solve that for x, and I get negative 3 over 2 would be where this graph crosses through the x-axis. And in the y-intercept, I'll let x be 0, so I'll just substitute a 0 in for x, solve this out, and my y-intercept, or where the graph crosses the y-axis, would be at 3. One way to graph this equation, which is a line that has no squares on the x or the y, is to just plot the x and y-intercepts and connect them with a line. So if my x-intercept is negative 1.5, I can go from the center, negative 1.5, and put a dot, and put a dot on my y-intercept of 3, and connect those with a line, and that's one way to graph. The other way, as you've already learned, would be to just pick out some x values, plug them in for x, and solve for what is usually called making a chart or a t-table of values. Where you you pick out an x, and then you put the x into the actual equation. For example, I can let x equal a negative 1, and I would say 2 times negative 1 plus 3. That gives a 1. For another ordered pair, I could let x be a 0. 2 times 0 plus 3 would give a 3. I could plot those 2 points, connect them with a line, and I would get the same line I already had by plotting the intercepts. In my math lab, you'll be asked to graph some equations. Let's say you're asked to graph negative x squared plus 4. First of all, you have to set the equation, make sure it's set equal to y, and then when you get this entered into your calculator, well actually we're just going to graph this one by hand, by plotting points. You just need to pick enough values for x to get several ordered pairs, since it's going to curve because of the square on here. 2 points will not work. You will need a quite lengthy table of values. I would always pick a couple of negatives, a 0, and a couple positives. Plug those into the equation. When I square a negative 2, I get positive 4. Then this minus over here makes it go back to negative. So I would have negative 2 squared plus 4. That's negative 4 plus 4. That's 0. Same thing when I put a negative 1 in and square, I get a positive 1, which turns back to a negative 1. And add it to 4, I get a 3. 0 squared plus 4, of course, is 4. 1 squared plus 4, I'll put negative 1 squared plus 4, that's also a 3. And negative of 2 squared plus 4 is a 0. Now you're going to have to, when you get ready to graph in my math lab, you're going to have to select, first of all, the curve. So there's like this, it's going to show you a line, a V, a curve. Anyway, this right here would be the U-shaped curve. It's just a square on X. You'll always get the U-shaped curve. So first you will select it, and then you'll have to plot your points, pressing enter after each one. Be sure that after you place the first 3 points on the grid, you must press an enter for it to actually place the points on there. If you don't press enter, it's going to show that you missed it when the points are actually on there correct. But you have to press an enter. Then you select and click save. And then you would check your answer. So this is just a little quick wrap up of a Section 1 overview. You need to go through the section in the e-text and study through the lesson and work out some of the examples. And then you will just go to your My Math Lab and start Section 1 homework assignments. And be sure to use those features to the right of each problem. You'll have media to watch, view an example, ask my instructor, help me solve this. All of those features are great, and the textbook's over there also. And then if you still need help, you can always send me an email or click that Ask My Instructor, and it will send a link to me with the specific problem, and I will get back to you with a solution.